This is a question from database management system. We have a set R of attributes A, B, C, D and E and have the following functional dependencies defined by F equal to A determines BC, CD determines E, B determines D and E determines A. Which of the following is not a candidate key? Options are A, B, E or BC. So for any attribute or set of attributes to be a candidate key, it is mandatory that it should functionally determine all other attributes. Therefore, to find the candidate key, first we need to find the closure of each of the options. What is closure? Closure is the set of attributes that can be functionally determined from a given attribute. So closure of A is the set of attributes that can be functionally determined from A and it is denoted by A plus. So closure of A is first A itself will be a part of its closure and the other attributes which are functionally determined from A. So A determines BC, B determines D and C and D determines E. We observe this from the functional dependencies that is given above. Closure of B is determined by B plus, B itself is a part of closure and B determines D. And we don't find any other attributes which is determined from this set. Closure of E is E determines A and since A determines BC, B determines D and CD determines E. Therefore closure of E is A, B, C, D, E. Again closure of BC is B determines D and B and C are itself part of closure and CD determines E and E determines A. Therefore again A, B, C, D, E is part of closure of B, C. Therefore we see that B is not suitable for a candidate key. Hence option B is the correct answer since it is not determining all other attributes in its closure. Therefore B is not a candidate key.